Hi, and welcome to the X Platform Microtutorials. This is Lesson 2, building out our first state replication project. My name is Kevin Goldstein, and I can be reached at the email displayed on your screen, which is kevin@neveresearch.com. A little bit about ourselves. The X Platform is authored by Neve Research, and you can find the homepage here. Also, everything we're going to be discussing today can be found in the Talon documentation. The link is also displayed below. There is a prerequisite, which is Lesson 1, setting up your development environment. Also, before we start jumping into code, let's quickly discuss what a state replication system does. First, it's a message-driven system. That means that it accepts messages from a source into a processor, which then does something with them, and then publishes the messages to a destination. Whatever changes it makes to its internal state, it is replicating those changes to the backup service. It does this so that in the event of a failure, messages will flow through a different route. This means that the source, destination, and service will seamlessly continue to operate as if there were no failure at all. In this tutorial, we'll build a project from Maven, explore the basic files, and build the project. Since this is a micro-tutorial, we will be running the most basic setup, which is a sender to a processor to a receiver. The processor, of course, will have a backup configured. First things first, let's navigate over to Eclipse. We're going to create a new project. This is going to be a Maven project. And since this is a SR processor, a state replication processor, we're going to call it a state replication. Now, since this is our first demo, let's call it Demo 1, and I'm going to call this SR processor. As you can see, this is generating our folders. Once it is completed, you can see the general outline of the project. Great, let's build it. If you're like me and like to run everything from the command line, now's the time to navigate to the terminal. Move into the directory and compile. Now, I'd like to point out this is the only time we're going to pop into a terminal during this lesson, since we dedicate an entire lesson to running this project from terminals, be it on your laptop or on remote machines such as a lab, for example. I'd like to bring your attention to a few things. First, inside models. Here there's an XML file called messages, where we define what our individual messages look like. If you open that, you can see that we have an entry for message and another entry for event. Now, if you look inside generated sources, you can see that we have classes for both a message and an event as well. These correlate one-to-one with the structures defined inside this XML file. Now, if you look inside the state folder, you'll see another XML file called state. Here's where you define the micro app state. And not surprisingly, this maps one-to-one with the classes in our generated sources. In this case, our construct is called repository. Another thing to pay attention to is this config.xml under the config directory. This file is responsible for configuring our entire micro app, so it's not surprising that the file gets quite large. I'm going to collapse it down here so that we can see areas of interest, which we'll come back to later into this tutorial. Now, if we recall from our introduction, we wanted to build a sender, processor, and receiver, and the archetype has conveniently created these for us. There is an application where message processing logic takes place. There is also a send driver and a receive driver. These are exactly what they sound like. They send messages and they receive messages. It's important to note that we are generating these as a convenience for you. In the real world, these sources and sinks will most likely be larger systems or other microservices themselves. The main focus point, at least for now, will be this method here. This is your message handler. This is where you would write your business logic. The X subsystem will identify incoming messages and hand them to you via this function for processing. I'm going to split this window out so we can see the definition side by side. Okay, good. Let's go ahead and make some changes to the message. Let's add a field here called message ID and another field here called user ID, which will just be a string of the message ID. It will be added to our Pojo directly and we can access it for use immediately. So let's have a look. Oops, something broke. Let's investigate. Yep, that's the field that we just removed, so this makes a lot of sense. Let's try and replace this with the fields that we just added. And as you can see, I can access these new fields with the autocomplete immediately. as pure Java objects. Those changes were on the sender side. Let's look inside the app itself. Please note that this message handler is giving you both the incoming message and the state that you have to work with. Let's go ahead and make a change here. Let's print out the new information. Now, if we do a full install or we run a test, we'll be able to see the output that is being tested from JUnit. And boom, there you see the printed output, as we expect. Great, but what happens if I want to have a new message? Let's add that in now. I'm going to call this new message epoch message. Now this message will not have an outbound message, just an update to a state. So let's create that message now. It'll have a field for tracking milliseconds since epoch, because, why not? There's a problem here. Let's see if we can find it. Oh, there it is right there. The ID is duplicated. You can't have duplicate IDs. You'll notice that as soon as I fix it, the message will pop up inside my generated sources. Next, what does a method signature look like? Let's navigate over to the app file. All I'm going to do here is make a copy of the previous method and the annotation that's important and add that in. Okay, I'm just going to print this stuff to the screen. Now, let's actually send some of these new message types. All I have to do is create a new message and use Java system time millis and make sure that that message gets put on the outbound channel. So, if I run this test again, we should see that we're getting interspersed messages, since that's exactly what I'm sending. And yes, that's what we're getting. Great. And so the next question becomes, do we always have to call this on message? That's going to get real confusing real fast. And the answer is no. We can call this method anything we want. It's the annotation and the signature that's important, not the method name. You can also pepper this throughout any classes in the code that you want, and we'll show some examples of that in later lessons. And that's it, ladies and gentlemen. That's the end of lesson 2. We've now built our first state replication project. Join us on lesson 3 for how to run these out of your terminal on either your laptop, your lab machines, or any combination of both. Please feel free to contact me at kevin@neveresearch.com, or you can always email us at our general contact account, which is contact@neveresearch.com. Also, feel free to poke around the Talon manual. It has a boatload of interesting information in there. Happy coding, everyone, and I'll see you on the next micro tutorial.